Okay, so I had a question about this, which I believe was an old quiz. And I sometimes when I work things, I just find out various stuff about the circuit, so it may not necessarily be answering, the actual quiz question, but just finding stuff out. But the quiz question says determine the power of the current source. So the way I like to do power is P equals IV. And we kind of have to do that on this one because we don't have a resistor, so we can't use any kind of resistance. Now the current is coming in on this side and going out on that side. So the V I'm looking for is the difference between VA and VB. So V equals VA minus VB. And that's what we mean by positive V, is the voltage at the side labeled positive minus the voltage at the side labeled negative. And the current coming into the side labeled positive means I'm going to write this as P equals IV. Alright, so let's label some voltages. If I just make this ground, so that means that I'm saying everything is relative to ground. Then relative to ground, ground is 0. And I have 18 volts up here, because on the other side of this voltage source I would have gone up by 18 volts. Now, going across a resistor, the voltage drop across a resistor is V equals IR. I know that the current in this entire branch down here, all of this, is 3 amps going in the clockwise direction, and it has to be because this is all in series. So it's 3 amps everywhere in there. And so the voltage drop across the 2 ohm resistor is 3 amps times 2 ohms is 6 volts. So I lose 6 volts going across the resistor. How do I know I'm losing 6 volts? If you have a positive current in the direction that you're going across a resistor, you're always going to be going down in potential in the direction that the current is going. So I've lost 6 volts, so that means at point A, my voltage at point A is 12 volts. Everywhere that's connected by a conductor without an element is at the same voltage, so we have 12 volts everywhere here until we get to the next element. All of that is at 12 volts. So that's all 12 volts. So that means I can now get I1 if I wanted to. I1 is going to be, anytime you're getting a current, it's going to be the current is the voltage on the side where you're starting. So if I have a resistor, if I have VA and R and VB, the current is VA minus VB, the voltage at the start, minus the voltage at the other end of the resistor over the resistor. So this is, I is going to be 12 volts minus, at the other end of the resistor we're at ground, so that's 0 volts, over 8. So that's 12 over 8, which is 3 over 2, or 1.5 amps. So I have I1 is 1.5 amps. I1 is 1.5 amps. I have coming into the node A, I have 3 amps here. I have 1 amp going off in that direction. I now have 1.5 going down there, so that means I2 must be 0.5 amps, because current coming in has to equal current going out, so I2 has to be 0.5 amps. Well, if I2 is 0.5 amps, that means that across this 12 ohm resistor I have another drop of 6 volts, because the drop is the current times the resistance, so it's 0.5 times 6, which is 6. And so if I was at 12 volts right here, I'm at 6 volts right there. I know that the current going down this branch is 1 amp, and I have a drop, a voltage drop here, of 1 times 7 equals 7 volts. So I have to be 7 volts higher on this side than I am on this side. So I have to be at 13 volts right here, because the voltage change across this resistor, has to be 7 volts. Because the current is 1 amp, 1 times 7 is 7. It has to be 7 volts. So if this side is 6, then this side has to be 13. So now I can answer my question. What is the power of the current source? So the power of the current source is going to be 12 minus 13 equals negative 1 volt. So that is the V, and the current is 1 amp, and so the power is negative 1 volt times 1 amp is negative 1 watt.